Hi and welcome back to the channel. A very cold West Cumbria. So the last few weeks there's been a lot of debate around T-type fuses and what fuses we should be installing in our vans. But before we get into that, we need to start looking at a few of the things that are vital in the selection of the correct equipment, and that is the professional term for what we're about to do. So everybody is banging on about T-fuses. Some say you should have them, some say you shouldn't have them. Hopefully by the end of this video you'll be able to make up your own mind. For me and my vehicle, they're a must. So let's get into this. But before we do that, there's a few fundamentals that we need to discuss. So there's quite a few things we need to understand before we select the correct fuse, and this is what we need to cover today before we start, and then we can talk about the right fuse, because at the end of the day this device is your circuit protective device. It's your means of automatic disconnection if something goes wrong. Very important. So I'm going to try and make this as simple as possible. When you're designing your system, your circuit, you need to work out what's going to be the biggest consumer of power. So for us, it was an air frying oven, and it was also a coffee machine, a Dolce Gusto coffee machine. That was pulling 1300 watts. This pulls 1700 watts. So when we were making our calculations, we also took into consideration our fridge that will be running all the time. That only consumes around about 100 watts at peak, and we added a little bit more on there just in case we needed to run anything else. So our starting figure was 2400 watts. Now we've got that in mind, we need to pick an inverter. Inverters, so there are a lot out there, and it's frightening. I know how hard it is when you're trying to make a decision on which one to fit. It's hard to work out what you need. So by having that figure in your head of, say we went with 2400 watts, we looked at what was available for us, and we went with the Vitron. The Vitron for us is the perfect choice because of all the safety features that are built into it. The fact that it'll invert up to 2400 watts. Depending on ambient temperature, it could do a little bit higher. I think it's around about 2700 watts. So that's ideal for us. There are a lot of inverters out there. They all do the same thing. Some do it better than others. That's all I'm going to say. And when you buy something like a Vitron, you're buying not just the product, you're buying that reputation as well, because they've been in this business a long, long time, and they're good at what they do. Bear that in mind when you're looking at inverters for a couple £100. Are you buying a good product, or are you buying just something that's been knocked up and banged out there? That's all I'm going to say on that. The next thing to consider is what type of battery you are going to install. So we have a number of different types out there, from lead acid to AGMs to lithium based batteries. All these different types will add a degree of factors that need to be considered when selecting your fuse as well. The next thing to consider is the cable, the size of cable, the current carrying capacity of the cable, and the type and make. Another thing to consider as well is the quality of your terminations. Making off your cable does have an effect, and it can be your weakest point. So selecting the right cable, making it off properly, and insulating it is a key factors to consider as well. So two things to consider when you're selecting your fuse. The size of the fuse. Now it doesn't want to be any greater than the current carrying capacity of the cables that you've installed. If it does exceed that, the cable will become your fuse. That's just keeping it as simple as possible. Now, your IR value. Your IR value is the amount of current that can travel into that fuse and it still works safely. It'll still disconnect without catching fire or blowing up or melting and arcing. still allowing that fault current to travel through it. That is the simplest way I can explain it to you. It's how much power can travel into that fuse and it still operates safely. If you put too much power through it, it will jump, it will explode, it could melt and fuse itself together and carry on carrying that fault current into your battery, into your devices. It's that simple. So now we've got all that out of the way, I'm going in the house because it's bloody freezing. I'm going to shut the garage door. We will go in the house, and I've got a few fuses just laid out and set up just to run through with you. I've got to keep an eye on that door because sometimes I forget and I leave stuff under the door and it chews it all up. So yeah, I think we're okay today. Yeah, it's got really cold out there, and as you might be able to tell, I'm not 100%. So let's have a chat about fuses now. So probably the first thing to talk about and discuss is the type of fuse you're buying and where you're buying it from. Now, if you're like me, you like a bargain, sometimes grabbing a bargain isn't the right thing when you're buying protective devices. I would always err on that side of caution, and I would use reputable firms, electrical factors, people like 12 Volt Planet and stuff like that, people who have to pay due diligence in what they're supplying. So they do all the checking for you, making sure that the fuses you are buying from them aren't snides and aren't cheap imitations. So for me, I have to do my homework like everybody else, my due diligence, and I go straight to the manufacturers. I've had lots of people ask me where I get the information from. I go to the manufacturers. Each reputable firm will produce a data sheet for the products they sell. If they don't, give them a wide berth. You need to know what they know about their product, and get one of these data sheets will tell you everything you need to know. The voltage range that it can be used in, the ampage that is available in that product. So you could have a 10 amp, 20 amp, 400 amp. It'll all be listed on the data sheet. You might have a few different variants on one data sheet, but it will all be there. So like I say, if you're buying a fuse and you can't get a data sheet from the manufacturer, don't bother. Do not bother. Let's have a look at the different types of fuse that's out there. So a lot of us use this. This is the mega fuse. It's not connected up, I'll just put it all together with a cover. So these are really good on smaller systems, and they're very practical, very affordable. The next type is the ANL, and again slightly bigger than the other one, and that is to allow you to connect bigger cables onto that. You would use this on slightly larger systems than the previous one, but you can use this on small systems as well. You know, it's how you want to make that application, but a nice little neat unit there. The next type, and this is the type that a lot of people like to use. It's been a well-used bit of kit in the boating industry for a long time. So this is a marine rated battery fuse, and it works really simple. This isn't the fuse. This is the fuse, sorry. Let me start again. This is a marine rated fuse. Now, these are great for confined spaces. When you apply it with this, it gives you a few more options. So this is a bayonet, a terminal extension. So basically, this is a plastic shroud that slides over here. You can bolt that onto your battery through that hole, and then it allows you to fit the fuse onto here. Just bear with us, bear with us, bear with me. I should have took that off. So a key thing to remember, this stud and this metal, this stud and this metal are not connected. The connection is made when you apply this fuse when you place that in position, see the surface area there, that needs to come into contact with the metal of this part. Now to make the connection, you add the washer, then a vibration washer or a split washer, and then you bolt it all down. And that, once bolted in place, will create your circuit. And when you torque it down to the right setting, and guess where you get that information from? Off your data sheet. You torque that down to the correct setting, and that is your marine rated battery fuse setup. That moves us on to the topic that everybody's talking about, the T-fuse. So this is a ceramic fuse that is full of silica sand, and that there, up until about 20,000 amps, will suppress, the sand will suppress the arc and put it out. Anything above that, and there's an opportunity for it to arc across from this side to this side and carry on putting the fault current through your devices and batteries and all the rest of it. So yeah, this one will handle considerably more power, and it's bigger for that very reason. So if you look at the little marine rated one, yeah, or you look at the mega fuse, these are considerably bigger, and for good reason as well. You're putting a lot of fault current through that. You don't want it melting, you don't want it falling apart. But it is considerably more money, so that is that. So we've had a look at each one of them. It's now time to start looking at the facts. So what we need to calculate now is the maximum short circuit capacity that our circuit could experience. So we have a lithium battery, a LiPo 4 Fogstar 6-weight battery, but when I've measured it, it's actually got 648 amps of usable power. Now, because of the way our battery is made up, it has very low resistance. So the rule of thumb we use to gain this figure is times by 10. So we'll round that up to 650. So 650 times 10 is 6,500 amp. So that is our ICC. That is the most we can expect to see under fault conditions, under short circuit conditions. Knowing that information will allow us now to select our IR on the fuse. So we need an IR value greater than 6,500 amps. Now, if you have a different setup to this, say you had a lead acid type battery, we'll use the same figure, so 650 times. Now, this is the bit that's interesting because of the way a lead acid battery is made up, it has a higher resistance, and because it has a higher resistance, that limits the amount of power that the fault can create. So we are down to a factor of 5. So the rule of thumb for a lead acid battery is 5 times the rateable value of the battery. So we would then be at 3,250 amp. So that is our ICC for that. Our IR needs to be greater than 3,250. So let's go and have a look at what our IR values are for each one of the fuses that we have here today. I've took the information off the data sheet for each fuse respectively. So the mega fuse can operate up to 32 volts, and the interrupting value of that fuse there is 2,000 amps at 32 volts. Same again with the ANL, that's slightly greater, it's 2,700 amps for that one. For the MRBF, it's 2,000 at 58 volts, and the T-fuse is at 20,000 at 125 volts. So that there is the only one I can use. By doing that short exercise, I've very easily established that the fuse I currently have in my van isn't capable, and this is why I've already bought the T-fuse. I've done this exercise before, but I thought I should share it with you. Again, I didn't consider it. I just picked a 400 amp fuse, didn't give it any thought, installed it, and it wasn't until somebody pointed out in my comments that I should be looking at the interruptible rate of the fuse that I've installed. That's when I started doing my homework, and I was like, oh yeah, that is a problem, and not something I considered. So, implications behind installing the wrong fuse. Under default conditions, that fuse would potentially operate, but runs a risk of catching fire, melting, arcing, and still creating a circuit. So that fault current wouldn't stop where it's supposed to stop at the fuse. It could then carry on into your cable, making that hot, basically igniting it and damaging everything downstream of that fuse. Now, I know what some people are going to say. Your BMS will protect you. You have overload protection, overcurrent protection built into your inverter. That won't protect you from this kind of fault. So if you have a short circuit in your battery and it's generating a lot of amps, the BMS ain't going to disconnect. Your inverter isn't going to shut down. The speed at which that power is going to hit them circuit boards, it's going to cause some damage. And this is what the beauty of this device is. It operates so quickly. It is designed for power systems. It is designed for sensitive equipment. So this will disconnect and hopefully no damage will occur to anything else in your van. So even after all that, we can get things wrong. I ordered what I thought was a 125 volt DC fuse, and it turns out this is an AC fuse. Now, I've been onto the suppliers, we've had a little bit of a conversation. This fuse is rated for DC installations as well, up to 160 volts, but it doesn't say that on the fuse. So I'm not going to install this. I'm going to hold out. I'm going to return this to the supplier, and I'm going to get one that states clearly it is for DC installations. I wouldn't recommend putting an AC fuse in a DC installation, even if it says on the data sheet. Why do they make DC fuses if AC fuses are okay? There's a reason somewhere. You'll be happy to know we're right at the end of the video, but there's a couple of things I want to touch on, and that is the quality of your workmanship. So when you're making off your cables, use the right tools, use the right products. Don't try and make things fit that shouldn't fit, because a loose connection in your van is basically where a fire will originate from. What happens is it builds up, it gets loose, it vibrates, it builds up a lot of resistance, that turns into heat then melts your insulation, and before you know it, you've got a fire on your hands. So for me, good quality crimping tools and good quality crimping techniques, and grounding. Make sure your batteries are grounded well, a big bolt in there. You want a metal to metal connection. If you've got a painted surface and you're putting your bolt through, serrated washers, also vibration washers, split washers, they're a must on every electrical connection for me. It's proven, you know, if you can stop something vibrating loose, it's going to half your worries and half your problems. Yeah, cable sizing as well. Make sure that you select the correct cable, because you don't want your cable becoming your fuse. You put the wrong size fuse in, the next place for that fault to stop is the cable that it's protecting. So just bear them in mind when you're doing all your little calculations and when you're buying your products. Cutting corners, I know it's expensive, I do know this, but buy it once, buy it right, and you'll be happy. Well, that's it for another week. We'll see you again. I hope you've enjoyed the video. I hope it's been beneficial. If it has, you know, give us a thumbs up. Hit the comment section if you've got any questions. And if you know anybody that this might benefit, please share it with them. If you're not a subscriber to the channel, please subscribe, because this is what keeps me motivated. When I see the subscribers going up and up and up, it does give me that little boost, and it gets me a bit more proactive as well. It gets me to get my finger out and get stuff done and make more videos like this. Anyway, take care and thanks for watching, and we'll see you again soon. Why not head over and check out our new website, www.thecraftyblinders.co.uk. Make sure to follow us on Instagram, TikTok and our Facebook group, The Crafty Blinder Van Builds. Thanks for watching.